Hi, I'm Miss Emma from St. Mary's County Library. Welcome to Fairy Tale STEM. Today we're going to explore the concept of heat transfer, but first I want to tell you a story. It might sound a little familiar to one you've heard before.
Goldilocks and the Two Bears. Once upon a time, there was a little family of bears who lived in a little house in the woods. Papa Bear and his child, Baby Bear. One morning, Papa Bear was stirring the porridge pot, getting it nice and hot for breakfast. He then took a spoon and split the porridge into equal portions into two large bowls, one large helping for him and the other large portion for Baby Bear. "Papa, that's too much porridge for me," Baby Bear complained. "You have to eat your porridge if you want to grow up big and strong," Papa Bear replied. Papa Bear set the bowls on the table and warned Baby Bear, "Careful now, the porridge is still very hot." "Let's go for a short walk and let it cool off a bit," said Papa Bear. While their porridge was left to cool on the table, the two went for a walk. Meanwhile, a local girl named Goldilocks was out picking flowers in the woods. Goldilocks would pick a flower and then move forward on to the next, and then the next, and in this way happened upon the bear's house. She knocked at the door, but no one answered. On her last knock, the door swung open and out drifted the delicious smell of porridge. Goldilocks' stomach rumbled at the smell. "I am so hungry," she thought to herself. "Maybe I'll just have a taste." First, Goldilocks tried the porridge in Papa Bear's bowl, but it was too hot. Next, she tried Baby Bear's porridge, and it was just the right temperature. "This is perfect!" she exclaimed. The porridge was so delicious that Goldilocks ate it all up. After a whole bowl of porridge, Goldilocks was feeling very full and decided to sit down and rest her eyes. Soon she was fast asleep. While she was sleeping, Papa Bear and Baby Bear returned from their walk. As they walked up to their porridge, Papa Bear noticed something was off. "Someone's been tasting my porridge," he mused. Then Baby Bear noticed her bowl was empty. "Someone's been tasting my porridge and they've eaten it all up!" Baby Bear exclaimed. Goldilocks was startled at the sound of Baby Bear's cries, and she woke up. Frightened, Goldilocks snuck out the window and ran home as fast as her legs could carry her. From that day on, the bear family was never bothered by Goldilocks ever again. The end. So today, we're going to discuss a question that I am sure was on the top of everyone's mind during that story. Why, if all of the porridge came out of the pot at the same temperature, was it too hot when Goldilocks tried the porridge from Papa Bear's bowl, but just right when Goldilocks tried the porridge from Baby Bear's bowl? The answer lies in a single detail, which some of you may have noticed. It is because the two bowls were made of different materials. Specifically, Baby Bear's bowl was made of metal, while Papa Bear's bowl was not. To understand why this is important, we first need to do a brief overview on the concept of thermal conductivity, or more simply, the way in which heat is transferred to an object. So there are two important facts to get out of the way first. One is heat is a form of energy. So whenever we reference energy from here on out, think of heat. The second is that all objects are made up of particles. They're tiny and you can't see them, but they're there. When energy is transferred to an object, the energy of these particles increases. This means the particles have more energy and they start to move and vibrate faster. As the particles are moving faster, they bump into other particles and transfer some of their energy to those neighboring particles. In this way, the energy is transferred through the substance. This process is called conduction. So what does this all look like in practice? I want you to grab some materials and let's demonstrate this concept. Grab a frying pan or other metal object and a plastic plate or other non-metal object. A quick note before we start. Make sure your objects are close to the same temperature. The easiest way to do this is just make sure they've both been left out at room temperature for a while before you start this experiment. Alright, with that out of the way, does everyone have their metal and non-metal objects? Good. So let's take a second and feel them both. Which one feels colder? The metal one, right? Now, as we discussed, this isn't because the metal object is actually colder, it just conducts heat away from your hand faster than the plastic does. The reason for this is related to what we just talked about. The particles in the metal object have a more organized structure than those in the non-metal object, which means that heat transfers from one particle to the next faster in the metal object than in the non-metal object. For that very reason, your hand feels colder on the metal object, and is also why Baby Bear's porridge cools down faster than Papa Bear's porridge. But again, you don't have to take my word for it. Let's go ahead and put this all into practice together. Go ahead and lay your metal and non-metal objects down side by side on the table. As you'll see, I'm using a metal pie plate and a glass pie plate just to eliminate the number of variables and to make it easy for you to see the ice cubes melt. So go ahead and grab 2 equal-sized ice cubes out of the freezer and place one of them on each object. Once you've done that, it's time to go ahead and watch them melt. Another note, the next video has been sped up, just so that you know what to expect while you're watching your ice cubes melt. Okay everyone, it's time to try it yourself. One last check, everyone should have one metal object, possibly a frying pan, one non-metal object, possibly a plastic plate, and 2 ice cubes of relatively equal size. If you don't have those, go ahead and pause the video and go grab them. As the video gets going, you will see we have 2 ice cubes, one on each plate. This video has been sped up, so your ice cubes will likely melt at a much slower rate than what is depicted in this video. But this way, you can watch the video to see what to expect and then experience it for yourself. So if you pay close attention to the metal plate on the right, you can actually see the material closest to the ice cube is getting colder, with the observable effect radiating out from the ice cube's position as the heat transfers from the metal plate to the ice cube, causing the ice cube to melt faster than the one on the glass plate. Just to touch on one additional detail, as well as this video being sped up, meaning this will be happening much faster than what you're actually seeing, another crucial factor related to this experiment is the temperature of the room in which you are doing the experiment. For example, if your room is hotter, your ice cubes are going to melt faster, and if it's colder, it's going to take longer for them to melt. So one variable that you could alter in this experiment is the time of year you perform it. If you were to redo this experiment in the summer, it is quite likely that your ice cubes will melt even faster than they are now. And of course, if it's already summer when you're doing this experiment, doing it in the winter would result in the ice cubes melting slower.
And there you have it. The ice cube on the metal plate had completely melted, while the ice cube on the glass plate remained only partially melted. Feel free to try this experiment again and see if you get different results. In science, it's important to gather as much data as possible to make your conclusions more certain. Thanks for hanging out with me, and we'll see you next time. Bye!